Hello, my name is Daniel, and today we'll be going through the AMC 12A from the year 2014. So let's get started. First problem, what is 10 times this much inverse, right? Okay, so first we can get this. That's going to be all over 10, and then 5 plus 3 plus 1, that's, plus 1, that's 8 over 10, that's 4 over 5. So that inverse, that's going to be 5 over 4, right? So we want 10 times 5 over 4, that's going to be equal to 25 over 2. So that's our answer, it's C. Number 2, at the theater, children get it for half price. The price for 5 adult tickets and 4 child tickets is $24.50. How much would 8 adult tickets and 6 child tickets cost? Okay, so since children are half price, that means we can count 2 children as 1 adult. So 4 child tickets, that counts as 2 adults. So 5 adult and 2 adult, that gives us 7 adult. So 7 adult is $24.50. So this gives us, that 1 adult, that is 24.5 divided by 7. That is going to equal 3.5. So 1 adult ticket is $3.5. Okay, so 8 adult tickets and 6 child tickets. 6 child tickets is equal to 3 adult tickets. So 8 plus 3 equals 11. So 11 adults, that's going to be 11 times 3.5. This is going to be equal to 38.5. So that's our answer. It's B. Number 3, walking down Jane Street, Ralph passed 4 houses in a row, each painted a different color. He passed the orange house before the red house, and he passed the blue house before the yellow house. The blue house was not next to the yellow house. How many orderings of the colored houses are possible? Okay, so let's say that Ralph went this way. So he passed the blue before the yellow, and he passed the orange before the red. And since the blue cannot be next to the yellow, that means if we have 4 like that, that means blue or yellow could be like that, or like that, or like that. And the remaining 2, those are going to be automatically filled in because the orange always has to be before the red. So that's just 1 configuration for each BY, right? So this gives us 3 configurations in total. That's the answer. It's B. Number 4, suppose that A cows give B gallons of milk in C days. At this rate, how many gallons of milk will D cows give in E days? Okay, so A cows, C days, this gives us B gallons of milk. So 1 cow in 1 day, this gives us B over A C gallons of milk. And for D cows in E days, that gives us BDE over AC. So that's our answer. It's A. Number 5, on an algebra quiz, 10% of the students scored 70 points, 35% scored 80 points, 30% scored 90 points, and the rest scored 100 points. What's the difference between the mean and the median score of these student scores on this quiz? Okay, so first, since we need to find out how much the rest is, and if you subtract 10, 35, and 30 from 100, that's going to give us 25, right? So this is 25%. So since they're all multiples of 5, if we just divide by 5 and say there are 20 students in total, then this will give us that 2 scored 70 points, and 7 scored 80 points, 6 scored 90 points, and then 5 scored 100 points. So the median, that is the 10th to the 11th, and the 10th and the 11th both are going to be here, so this is going to be 90 points. So that's our median. And for the mean, that is going to be, mean, that's going to be all over, and then it's 2 times 70, plus 80 times 7, plus, and then 90 times 6, plus, and then 5 times 100, all over 20, because there's 20 in total. So this is going to be equal to 7 plus 7 times 4, that's 28, plus 3 times 9, right, that's going to be 27, plus 5 times 5, that's going to be 25. So that's equal to 87. And so this is our mean, and the difference is 3. So that's our answer, it's C. Number 6, the difference between a 2-digit number and the number obtained by reversing its digits is 5 times the sum of the digits of either number. What's the sum of the 2-digit number and its reverse? Okay, so we have numbers 10a plus b, and its reverse is going to be 10b plus a, and if we subtract them, their difference is going to be 5a plus b, like that. And so this is going to give us that 9a minus 9b equals 5a plus 5b. Therefore, 4a equals 14b. And since a and b both have to be single-digit numbers, that means that a is going to be 7 and b is going to be 2. So our numbers are 72 and 27. And we want the sum, so 72 plus 27, that's going to give us 99. And there's our answer. It's 99. It's D. Number 7. The first 3 terms of a geometric progression are this, this, and this. What's the 4th term? Okay, so putting those in exponential form, that's going to be 3 to the 1 over 2, and this is going to be 3 to the 1 over 3rd power, and then this is going to be 3 to the 1 over 6th power, right? But we know that those can be expressed in all over 6, so it's going to be 3 to the 3 over 6 power, and then 3 to the 2 over 6 power, and then 3 to the 1 over 6 power. And then the next is going to divide by 3 to the 1 over 6 power, so this is going to be 3 to the 0th power, which is just basically 1. And that's the next term. That's our answer. It's A. Number 8. A customer who intends to purchase an appliance has 3 coupons, only one of which may be used. Coupon 1 gives us 10% off the listed price, $20 off the listed price, and 18% off the amount by which the listed price exceeds 100. Okay, so since all of these are over 100, then all of these conditions aren't going to match. First one, if our listed prices, if we call these X, then the amount that is discounted, that's going to be 0.1x, and this much is, it's always going to be $20, and this much is, and coupon number 3, that's going to be 0.18 times x minus 100, and so this is the amount that is discounted, so we want the one that is the largest, and we want this one to be the largest. That means 0.1x has to be greater than or equal to, no, just greater than 20. This gives us x is greater than 200, and for these two, 0.1x has to be greater than 0.18, 0.18x minus 100, yeah, x minus 100, this gives us 18 is less than 0.08x, so that gives that x is less than all over 8, and 18 times 100. This is equal to 9 times 25, which is equal to 225. Summing those together, that gives us x is between 200 and 225, and 225, so the only value of x between those numbers is C, so that's the answer. Number 9. 5 positive consecutive integers starting with A have average B. What's the average of 5 consecutive integers that start with B? Okay, so if we have 5 consecutive positive integers, then their average is going to always be A plus 2. So we know that B is equal to A plus 2. And we want the average of 5 consecutive integers that start with B. The average of 5 consecutive integers that start with B is going to be 2 plus B. So 2 plus B, this is just going to equal, substituting that, A plus 4. And just that's our answer, very simple. It's B. Number 10. 3 congruent isosceles triangles are constructed with their bases on the sides of an equilateral triangle of side length 1. The sum of the areas of the 3 isosceles triangles is the same as the area of the equilateral triangle. What is the length of one of the 2 congruent sides of one of the isosceles triangles? Okay, so we can get this, get that equilateral triangle. And since the sum of the areas of the isosceles triangles is the same as the area of the equilateral triangle, we can just say that the isosceles triangles are facing inside, like that. And so that's going to give us something that looks like this, like that. And now we can see that these will be our 3 isosceles triangles. And this perfectly makes sense, because the sum of the areas of these 3 things is just the area of the whole thing. And so that means the length of one of the 2 congruent sides, that's this length. And since it has side length 1, so this is 1. And so now, if this is 1, then we can separate this into like that. And this will be 1 over 2. So if that's 1 over 2, and this is 60 degrees, right, because we're dividing into 3 equal parts, that will mean that this length is going to be, so that's going to be 2 over root 3 times this length, which is 1 over 2. That's going to be 1 over root 3, which is root 3 over 3. And there's our answer. It's B. Number 11. David drives from his home to the airport to catch a flight. He drives 35 miles in the first hour, but realizes that he will be 1 hour late if he continues at this speed. He increases his speed by 15 miles per hour for the rest of the way to the airport and arrives 30 minutes early. How many miles is the airport from his home? Okay, so if he increased his speed 50 miles per hour, that just means that he was going 50 miles per hour. Now we have to focus on the time difference. If he went for 35 miles per hour, then he will be 1 hour late, but then since he went 50 miles per hour, he was 30 minutes early. So that basically means that if David drove X miles at 50 miles per hour, then we can say that X over 35, which will be the time taken if he had just kept on driving 35 miles per hour. This is just going to be equal to X over 50, so his actual time, plus 1.5 hours. And that's because he would have been 1 hour late, but he became 30 minutes early. That means this is plus 1.5 hours, right? And so if we cross multiply, we get 50x equals 35x plus, and then 15 times 5 times 35, because we just made the make the decimal point go away. So this gives us that 15x equals 15 times 5 times 35. That means x equals 5 times 35. So this is going to equal 175. But then this is just the distance that he drove at 50 miles per hour, right? So before that, he had driven 35 miles more. So what we have to do is sum those two together. So 175 plus 35 is going to be equal to 210. So 210 miles, that's the answer, it's C. Number 12, two circles intersect at points A and B. The minor arcs AB measure 30 degrees on one circle and 60 degrees on the other circle. What's the ratio of the larger circle to the area of the smaller circle? And so first, if we draw a diagram of this, it's going to look something like that. So those are going to be the two circles, and this is A, and this intersection is B. And if we can connect them, right, that's going to be our AB. And the minor arcs AB measure 30 degrees on one circle and 60 degrees on the other. That basically means that if we have like that connection, and that's going to be 30 degrees, and this, yeah, so that's going to be 60 degrees. So this is 60, and this is 30 degrees. And so we want the ratio of the area of the larger circle to the area of the smaller circle. That means that we can just get the ratio of the radii and then just square them. And so now what we want to do is we want to connect a line from here to there. So that's going to make this whole triangle. And since this is 30 degrees and this is 15 degrees, we can use the sine of 30 and 15 degrees to get our answer. So let's say that this is, so let's say that that radius is 2. That means that this is going to be 1. And so this, so since this much is 15 degrees, that means that this length is going to be 1 over sine 15 degrees. This is going to be 1 over, and then we know that sine 15 is root 6 minus root 2 over 4. And if you don't know this, memorizing it will be good for you. So this is all going to be equal to root 6 plus root 2. And so we know that this length is root 6 plus root 2 now. So we want the area of the larger circle to the area of the smaller circle. So since it's area, we have to square them. So it's root 6 plus root 2 squared over, and then 2 squared. So 4, and this is going to be equal to all over 4, and then 8 plus 4 root 3. That is equal to 2 plus root 3, and this is our answer. It's D. Number 13, a fancy B&B inn has 5 rooms, each with a distinctive color-coded decor. Okay, so what that basically means is that these 5 rooms are distinct. And one day 5 friends arrive to spend the night. There are no other guests that night. The friends can room in any combination they wish, but with no more than 2 friends per room. In how many ways can the innkeeper assign the guests to the rooms? Okay, so the first way is if everybody sleeps in different rooms. So 1, 1, 1, 1, 1. So that's just going to be 5 factorial ways of putting each person in each room. And next, 2 people could group together. So that's going to be 2, 1, 1, 1, like that. And that would be just 5 choose 2, because we have to choose which of the 5 will go into 2 groups. Sorry, will go into the group of 2. And then since we have 4 groups now, that's going to be just 5p4. And lastly, we can have group of 2 and 1 left over. That's going to be 5 choose 2 times 3 choose 2. That's going to be for these 2 groups. But then since I'm choosing these 2 and then these 2 is equal to choosing these 2 and these 2, that's just going to be, we have to divide it by 2 because of the overlap. And then we have to multiply that by 5p3 because we have 3 groups in total. And so if we compute everything, this is going to give 120. This is going to give 120 times 10, so that's 1200. And this is going to give, this is 60, so this is 60 times, and this is 10, and this is 3, so it's going to be 15. That's equal to 900. So if we add all of these together, then we're going to get 2,220, and that is our answer. It's B. Number 14, let B is between A and C be 3 integers such that ABC is an arithmetic progression, and ACB is a geometric progression. What's the smallest possible value of C? Okay, so since ACB have to be a geometric progression, then we'll say that A is just A, and C is AR, and B is AR squared. So if that's the case, then ABC has to be an arithmetic progression. That means it has to be AR squared, and then AR, like that. So since their differences have to be equal, this gives us that R squared minus 1 is equal to R minus R squared. So this gives us that 2R squared minus R minus 1 equals 0. And so this can give us that R can equal minus 1 over 2 or 1. So R can be minus 1 over 2 or 1, but we see that R cannot be 1 because B and A and C, they cannot be equal. And if R was 1, then they would all be A. So R cannot equal 1, therefore R must be negative 1 over 2. So if R is negative 1 over 2, that means these 3 values, they are going to be A and 1 over 4A and minus 1 over 2A. But then if A is positive, then this is just going downwards. But then C has to be greater than B, it has to be greater than A, so it must be an increasing sequence. So what this gives us is that A is less than 0. A is a negative number. So the smallest way for C, that's when these are barely just integers. So that's when A is negative 4. So a is going to be -4. That's going to give us that it's -4, and then it's -1, and then it's 2. So that is an arithmetic sequence, and our c value is going to be this one. That's the answer. It's 2. It's C. Number 15. A 5-digit palindrome is a positive integer with respective digits a, b, c, b, a, where a is non-zero. Let s be the sum of all 5-digit palindromes, or it's the sum of the digits of s. Okay, so first of all, we know that for a we can have 9 values, 1 to 9, and for b and c we can both have 10 values from 0 to 9. So this is 10 values and this is 9 values. So all the sum of the a's, this is going to be the sum of 1 to 9 multiplied by 100, because if we have just one set value of a, then we can have 10 possible b's and 10 possible c's, so that's going to give us 10 times 10. That's why this 100 is there. And same thing, the sum of b, that's going to be 0 to 9 sum times 90 this time. And that's because if we set a value of b, then that means we can have 9 possible values of a and 10 possible values of c, so it's 9 times 10, which is 90. And same thing for c, we have 0 to 9 possibility, and times 90, because if we set one c, then we're going to have 10 possible b's and 9 possible a's. They're going to multiply to create 90. And so if we just add all of these up, this is going to be, this is 45, 45, 45, right? So it's 4,500. So if you see, then a, b, c, b, a, they are in different digits. So the sum of a is, so the sum of this one is going to be 4,500, and the b, that's going to be one lower than that. So yeah, this is 4,500, and this is 45 times 90, which is 4,050, and this is also 4,050, right? So if we have 4,500, then the next thing is going to be one digit lower, so 4,050, and then c 4,050, and then one more b, so 4,050, and then lastly a, so that's going to be 4,500. And so if we add these up, then we can get 495,00000, and the sum of these digits, this is going to be 4 plus 9 plus 5, which is 18, and that is our answer. It's B. Number 16, the product 8 times 8888 all the way to 8, where the second factor has k digits, is an integer whose digits have a sum of 1000. What is k? Okay, so if we do that, then this is going to be equal to just 64 times 11111, and then this is going to be k times. And if we do that, then we will find that we have 64 and 64 with one digit getting lower, 64 all the way to 64 like that, and we have to add all these up, and there are k of these numbers. So there are k numbers. So if we add them up, then we are going to find that these two make up 10. So that's going to give one carry up, and same thing, one carry up, 1, 1, 1, 1, all the way to this one. So that's going to give k minus 1 tens. So this is going to give k minus 1 ones, right, because of the carry, and then plus we have the 6 and this 4. So we have this 6 and this 4, so plus 6 plus 4. And this is going to be equal to 1000. Equals 1000. So k minus 1 equals 1000 minus 10, which is 990. So k equals, so k equals 991, and that's our answer. It's D. Number 17, a 4x4x8 rectangular box contains a sphere of radius 2 and 8 smaller spheres of radius 1. The smaller spheres are each tangent to the 3 sides of the box, and the larger sphere is tangent to each of the smaller spheres. What is H? Okay, so if we run into circles or spheres or anything, first thing that we want to do is connect to their centers. So I'm going to label each of these centers here, and for the ones in the back, I'm just going to say that those are like about here, like that, right? And so if we connect those centers together, we'll get a shape. And that shape is going to look something like this. That's going to be right about here, like that. Okay, and the next thing that we're going to do is that find that this big thing is radius 2, and the small sphere has radius 1. That means we know that this much, so right here, that's the, that's where they meet. That's going to be 2, and this is going to be 1. That means the whole thing is going to be 3. So this side length is going to be 3. And since this is 1 and this is 1, that means that that's going to be 2. And same thing for here, that's also two radii meeting, so that's also 2. And what that gives us is that it gives us the length from this diagonal. And so that diagonal is going to be 2 root 2, because this much, that's going to be a 45, 45, 90 degree triangle. So this much is 2 root 2. But now what we want is the h, so that's the height of the thing, so that's the height of the whole thing. And since we know that if we have like this, this plane, and then the distance up from it is equal to just 1 radius, and same thing down here, the distance down is just 1 radius, that's 1. And so if we just know this height, so if we just know that height, and we multiply that by 2 to get to this height, and then we tack on 1 and we tack on 1 and 1 more, like that, that's going to give us the whole height. So if we say that the height right here, if we say that this is just x, then the height is going to be equal to 2x plus 2. So this makes up the 2x, and this is going to be the 2, that's right. And then now we can use Pythagoras, because we see that right here, that's a right triangle, and we can see that this much is x, and this much, that's half of 2 root 2, so that's just root 2, and this much, that's just 3. So if we take that out, that's going to be like that, x and root 2 and 3. This gives us that x is equal to root 3 squared minus root 2 squared, which is root 7. So 2x plus 2 equals 2 root 7 plus 2. And that's our answer, it's A. Number 18, the domain of the function fx equals this monstrosity is an interval of length m over n, where m and n are relatively prime positive integers. What is m plus n? Okay, so the domain, that's the x values when this is, that's the x values when this thing is defined. So for a log of something to be defined, that means that this has to be positive. So log 4, and then log 1 over 4, and log 16, and log 1 over 16 of x has to be defined. So that has to be greater than 0. And if the log of something has to be greater than 0, that means the thing inside here has to be greater than 1. So that means if we take that away, then this is going to be greater than 1. And for the log 1/4 of something to be greater than 1, that means that this thing inside has to be between 0 and 1/4 to the first power. So that's going to give us something like, so that's going to give us that this is between 0 and 1/4 to the first power, that's just 1 over 4, right? And then taking this 16 out now, that's going to be, so that means that this middle thing is going to be between 16 to the 0 power and 16 to the 1 over 4 power. So that means that this thing, that is going to be between 16 to the 0th power and 16 to the 1 over 4th power. 16 to the 0th power is just 1, and 16 to the 1 over 4th power is just 2. And now x is going to be between 16 squared and 16. 1 over 16 squared and 1 over 16. That's going to be 1 over 16 squared and 1 over 16. And this much, that's just going to be equal to 1 over 256. So 1 over 256. And so this is our x. So the length m over n, that is going to be, so m over n, this is going to be 1 over 16 minus 1 over 256, which is just 15 over 256. So this is our m, this is our n, and m plus n, that's going to be equal to 271. So it's 271, this is the answer, it's C. Number 19, there are exactly n distinct rational numbers k such that the absolute value of k is less than 200, and 5x squared plus kx plus 12 equals 0. That has at least one integer solution for x. What is n? Okay, so for this k's upper bound is 200, so the k's upper bound, so the upper bound for x would be when k is equal to 200. So if we put that in, then that means that 5x squared plus 200x plus 12 is equal to 0. So this would give us that x is going to be equal to, if we use the quadratic formula, all over 5 and then negative 100 plus or minus a root of 1 of 10,000, and then minus 5 times 12, that's 60. So this is going to be plus or minus root of 9940, and then minus 100 all over 6. So if you try this, then you will find that that is going to be between negative, so that's going to be like about negative 39. So that means that x can be all possible from minus 1 to minus 39, and this is 39 values for k. So this is 39 values for k, but then it said that the absolute value of k has to be less than 200. That means that we can have negative values for k also. So that means we just multiply 2, so it's 39 times 2, which equals 78. And we can have 78 values of k. That's our answer, it's E. Number 20, in triangle BAC, angle BAC is 40 degrees, AB is 10, and AC is equal to 6. points D and E lie on AB and AC respectively, what's the minimum possible value of BE plus DE plus CD? Okay, so this is going to be equal to, if we draw that out, then that's going to be looking like this. So we have B, and then A, and then C like that, and AB is 10, and AC is 6, and D and E are on AB and AC, so this is D, and this is going to be E. And then we want the minimum possible value of BE plus DE plus CD. That's going to be, if we connect that, that's going to be this much, right? That's going to be this much. But then how can we be sure that we have the minimum? And that is by, if we reflect C over AB like this and then go that, and so let's say that that's C prime, and do the same thing for B. Reflect B over AC, then that's going to give us something like this. No, maybe we're going to have something like C is going to be here, like that, and our B reflected over like that, that's going to be something like that. So this would be B prime, and this would be C prime. And since these are just reflections, that means that BE is going to be equal to EB, EB prime, and DE is just going to be that, and DC is going to be equal to C prime D. And so the minimum possible value of that would be if this is just one straight line, right? And so if we bring that thing over here, that's going to look something like this. So this is when B is flipped over like that to B prime, and C is flipped over here, so to C prime. And so if we draw a line between C prime and B prime, that is exactly going to be what CDEB prime looks like. So that means we want this one to be a straight line. That means AC prime B prime has to be an actual triangle. And since it gave us that BAC equals 40, that means this is 40. And since this is just a flip, that means this is also 40. Since this is a flip, that means this is also 40. That means the whole thing is going to be 120. Whole thing is 120. And so now we can use the cosine law on triangle AC prime B prime. So using the cosine law, that's going to give us B prime C prime is equal to 6 squared, because this is 6. So since this is 6, that means this is also equal to 6. Since this is 10, that means this is also equal to 10. So that means this is 10. So it's 6 squared plus 10 squared, and then minus 2 times 6 times 10, cosine 120, right? And we know that cosine 120 is equal to negative 1 over 2. So this is just going to be plus, and then these two are going to cancel. And so this is going to be equal to 36 plus 100 plus 60. This is equal to 196. And so this is B prime C prime squared. So B prime C prime, this is going to be equal to root 196, which is 14. So this is the minimum possible value of this length. And so that means that's also the minimum possible value of this thing. And so this is our answer. It's 14. It's D. Problem number 21. For every real number x, let the floor of x denotes the greatest integer not exceeding x, and let fx equal the floor of x times 2014 to the x minus floor of x power minus 1. The set of all numbers x such that x is between 1 and 2014 and fx is less than or equal to 1 is a union of disjoint intervals. What is the sum of the lengths of these intervals? Okay, so first of all, let's consider the case where x is between 1 and 2, because that's our smallest interval. So if x is 1 plus some small number, let's say a, and of course a has to be between 0 and 1, like that, then that will mean that the floor of x is equal to 1. So if we just put that in there, then this gives us that the fx is going to be equal to 1 times 2014 to 1 plus a minus 1, so that's just going to be a, and then minus 1. So this should be less than or equal to 1. Less than or equal to 1. This gives us that 2014 to the 8th power, this is less than or equal to 2, which means that a should be less than or equal to log 2014 of 2, like that. Next thing is if x is 2 plus a, this will give the floor of x is equal to 2, and same thing, that will be, this is 2, so it's 2 times, and then 2014 to, it's 2 plus a minus 2 now, so that's going to be 2014a, like that, and then just minus 1. This should be less than or equal to 1. This gives us that 2014 of a, 2014 to the 8th power must be less than or equal to, must be less than or equal to 3 over 2. This gives that a is less than or equal to log 2014 of 3 over 2. But then we can separate that, we can separate that into log 2014 of 3 minus log 2014 of 2. And then, log 2014 of 2. But then now we can see that something really amazing is happening because we wanted the sum of these intervals. And so these are going to be the sum, right? So those are going to be the length. And their sum is going to be, these are going to cancel out, right? And let's see if this pattern will hold. Now, so let's try 3 plus a. This is going to give us, this is just equal to 3. The floor of x is 3. This is going to give us 3 times the same thing is less than or equal to 1. So that means 2014 to the 8th power is less than or equal to 4 over 3. And yes, it is the same because a is less than or equal to log 2014 of 4 minus log 2014, 3. So we can see that this are also going to be cancelled. And so this cancellation with just leaving this thing is going to continue up until the maximum possible value of x. And since x has to be less than 2014, then yeah, the final value of x, that will be, it's going to be 2013 plus a. And so this is going to give us, if we look, it's going to be log of 2014, and then if this was 3, this was a number 1 greater than that. If this was 2, this was 1 greater than that. So this will give log 2014 of 2014, and minus log 2014, 2013. And we can see that all of these are going to cancel, and this is also going to cancel, which leaves us only with this. But these are the same, that means that's just all going to be 1. So 1 is the answer, it's A. Number 22. The number 5 to the 867th power is between 2 to the 2013 and 14 power. How many pairs of integers m, n are there such that m is between 1 and 2012 and this holds true? Okay, so first we have to look at what this means. This is not spaced 1 apart. That's actually spaced 2 apart. That means there's 2m and 2 to the m plus 1 power, m plus 1 power, and 2 to the m plus 2 power in here. And so this means that between consecutive powers of 5, there are 3 powers of 2. So if we list the powers of 2, it's going to be 2, 4, 8, 16, 32, 64, 128, 256, 512, and then 1024, and 2048, and so on like that. But then if we superimpose the powers of 5, then that's going to be 5 is going to be here, and 25 is going to be here, and 125 is going to be here, and 625 is going to be here, 625, and then the next part is going to be here, and so on like that. And so now we see that this is definitely not common because we usually have 2 powers of 2 between consecutive powers of 5. But then in this case, that's when there's 3 powers of 2 between consecutive powers of 5. So if we write this out, then that means there's mostly 2 powers of 2 between powers of 5, but sometimes 3 powers are going to exist. 3 powers are going to exist between consecutive powers of 5. And so we want the number of, so we want just how many sets there are in this 3 set. And so to get that, we just have to get this 2013, because that's all the powers of 2. So that's going to be 2013. And then we are going to subtract 2 times 867. We are going to subtract 2 times 867 because 5 to the 867, it's just right over there. And this is going to be so that's going to be subtracted twice because normally there's 2 of these like that, right? 2 of these like that. And we can subtract 2 of these from here too. So we can subtract 2 from here, but then that's still going to leave this thing. So that's still going to leave 1 more. And so the numbers that are left from here, that's going to be the numbers that are left from this one. So that's just effectively counts the numbers of these 3 number kind of sets. So if we compute this, this is going to be equal to 2013 minus 1734 equals 279. And that's how we get that 279 is our answer. It's B. Number 23, the fraction 1 over 99 squared equals 0. And then this all the way to be 0. Where n is the length of the period of the repeating decimal expansion. What's the sum b0 plus b1 all the way to bn minus 1? Okay, so there isn't really any other way to do this. So it's just going to be, we have to actually calculate 1 over 99 squared. So first of all, we'll just divide 1 by 99. We know that this is just equal to 0.010101 like that. It keeps on repeating forever, like that. But then now we have to divide this by 99. And that's just what we have to do. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. We don't know how many we need, but we are going to need a lot. So if we divide by 99, then first of all, our first division occurs right here. So that's going to be 1. We can divide by 1 time, and all before that is going to be 0. So if we divide once, then that's going to be 99. That's going to leave 2. So 2, 0, 1, And again, here we can divide twice because this increased by 1. So that's going to give 198. That's going to give 301. And then now we can do it 3 times, and that's going to give 290s. Yeah, that's going to give 297, which leaves 401. And now we kind of see the pattern because we had 101, and then we had 201, we had 301, 401, and we see that this is going to keep going. Because every 2 steps we just multiply 100 to the last difference, and that difference keeps increasing by 1 because we're dividing by 99, which is 1 less than 100. So that means this is going to keep going, and so this is going to be 0, 0, 0, 1, 0, 2, 0, 3, and then it's going to keep going like 0, 4, 0, 5, 0, 6, all the way. But then we have to notice that 99 squared, this is equal to 9801. So it's 9801. And since we notice that all of these end with 01, that means somehow, somewhere, we are going to end up with something, 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 and then 9801, like that. And so, when do we get to this? So, 101, that gave us 1, and 201, that gave us 2, 301, that gave us 3, and so that means 9801, that's going to give us 98, and before that would have been 97. So before that would have been 97. So until 97, it's all good. But then after that, we get 9801. And see, since 99 squared is 9801, that means that exactly 99 9801s, exactly 99 99s can fit inside 9801. And then this is going to go back to 0. And then that just means that this starts all over again. So this is going to repeat. And so now we finally found the part that's being repeated. That's going to be this much. So we just have to add up all the kind of digits. So it's just all the digits from 1 to 99, except that we don't have 98. So we can just take the sum of everything and then subtract 98 later. That's going to be, we're going to have 10 of everything in 10's digit, and we are also going to have 10 of everything in the 1's digit. So just multiply 20 to everything. That's going to be 1 to 9 times 20, which equals 900. But then we have to take out the ones for 98. So 900 minus 9 minus 8, this is equal to 883. So 883, that's our answer, it's B. Number 24, let f0 of x be x plus the absolute value of x minus 100 minus the absolute value of x plus 100, and for n is greater than or equal to 1, let fnx equal this thing. For how many values of x is f100 of x equal to 0? Okay, so first of all, let's just try plugging in some values for f and x, because we don't really want to deal with this now, so let's just focus on this one for now. And so, if we just say that f0x is some random number, let's say f0x, let's say this is just 3. f1 of x, this is going to be the absolute value of this minus 1, that's going to be 2. And then f2 of x is going to be 1, because it's 2 minus 1. And then f3 of x, that's going to give us 0, because we're going to be 1 doing 1 minus 1. And f4 of x, that's going to give us minus 1. And then f5 of x, this is going to give us the absolute value of minus 1, the absolute value of minus 1, right? So that's just going to be 1 minus 1, that's just 0, back to 0 again. So that means that after we reach 0, then it's going to keep repeating this 0 minus 1, 0 minus 1, 0 minus 1, like that. So the pattern is that whatever value we start with, we just keep decreasing until we get to 0, and then from then on we just keep repeating. And so once the number hits 0, it will just keep repeating. It will repeat 0 and minus 1, and it hits 0 at the actual number. And so if you see here, we hit 0 at f3, and that 3 is exactly this number. If this was 4, then we would have gone up down to 0, and this would have been 4. And so hit 0 at the f of the starting number, because the starting number was 3. 3 is where we hit it. And so we want f100x to be 0. So for f100x to be 0, for f100 of x to be 0, and then that means that we must hit 0 at an even number. You might say, why suddenly even numbers? But then if you look here, if you start with an odd number, then you are going to hit 0 at an odd number. Because of this, it will hit 0 at f of the starting number, and so it's going to hit 0 at the odd number, and after that it's going to alternate 0 and minus 1. That means it's going to be 0 at odd numbers only. But then f100, that's an even number, so for f100x to hit 0 at an even number, that means we should start with an even number. That's why it must hit 0 at an even number. And so that means f0 of x, this can be all the even integers from 0 to 100. And now we go back to this thing and we compute that. So this just divides into 3 cases because we want to get rid of those absolute values. If x is greater than or equal to 100, then that gives us that f0 of x. So f0 of x is going to be equal to, and then no, yeah, and then those are going to just disappear, the absolute values. So that's going to give us just x minus 200. And so x minus 200 has to go from 0 to 100. But x has to be greater than or equal to 100. This gives us that x goes from x goes from 100 to 300. And next, if x is between, right? So if x is greater than or equal to minus 100 but less than 100, this is going to give us that f0 of x. That's just going to be minus x. And so this is going to give us that x can be from minus 100 to 100, because just minus x, that's just from 0 to 100. And since x is between minus 100 and 100, that's going to be this. And lastly, if x is less than minus 100, this just gives us that f0 of x. This is going to be equal to 200 plus x. This gives us that this can go from 0 to 100, and so that means that x can go from minus 300 to minus 100, like that, right? And so what we do now is we add all of these things together. This is going to give us that x is greater than or equal to minus 300 and less than 300. And so this gives us 600 values, but then it must add an even number. So it's all even integers between 0 and 100, so x must be even. So the even integers, that's just 600 over 2, which is 300, but then we have to plus 1 because we have both sides have equal signs, so this is 301. So 301, that's our answer, it's number C. Last problem, number 25. The parabola P has focus 0, 0 and goes through the points 4, 3 and negative 4, negative 3. For how many points x, y within P with integer coordinates is it true that 4x plus 3y's absolute value is less than or equal to 1000? Okay, so first let's try to draw this parabola. So this is the parabola's coordinates, and this is the focus 0, 0, and it goes through the points 4, 3 and minus 4, 3, something like that. And so if we have those 2 points, then it's going to look something like this, like that, and this is going to be like 4, 3, and this is going to be like minus 4, minus 3, like that. And so this gives us that x, y has to be within P. So since this parabola is like very tilted, and we don't want that, so we want to rotate the parabola to something that looks more normal, like that. So something that looks like this. And so if we do that, that means that we have to turn it clockwise. So we have to rotate clockwise by theta, and that theta is just going to be this angle. This is going to be theta. So this basically means that we have to rotate it clockwise by this angle, right? So let's call this angle theta. So this will be theta. So it has to rotate clockwise by theta. And since we notice that if we draw a right triangle like that, this is 4, this is 3, and this is 5, that means that's a 3 to 4 to 5 right triangle. This means that we can know the sine and cosine values of theta. So sine theta, this is going to be equal to 3 over 5, and the cosine theta, this is going to be equal to 4 over 5. And next, what we want to do is we want to get x, y values of this one to u, v values. And so x, y, we want this to become u, v, and that's going to be values on here. So we know that x, y, that's if we put it in polar form, x, y, this is going to be in r cosine theta, r sine theta. But then what we want now is for this to be rotated like that. So clockwise, that's negative, and so that means u, v, this is going to be equal to r cosine theta minus theta. So cosine of theta minus theta, r sine of theta minus theta. And so this is going to be equal to, so if we separate the sines and cosines, that one is going to be equal to, and then r cosine theta something plus something separated, that's cosine something, cosine of the other something, minus r sine theta and sine minus theta, like that, and then comma, we have this one, so to separate that one, it's going to be r sine theta cosine theta plus r cosine theta this shouldn't be cosine theta, that's cosine minus theta, right? Cosine minus theta plus r cosine theta sine minus theta, like that. So those are all of the coordinates. So we can see that r cosine theta, r sine theta, those are x and y, and so we can plug those values into here. So this is going to be equal to, so that's going to equal 4x plus 3y over 5, comma 4y minus 3x over 5, like that. And so these are the u comma v values, and notice that these are on this parabola, and that parabola, this one, this mesh is 5 comma 0, and so this is also minus 5 comma 0. So this gives us that this so that parabola is u squared equals 10v plus 25. So u squared equals 10v plus 25. If we put this as u and this is v, then this is going to give us that u squared equals 10v plus 25. This is u and this is v. We just multiply 25 first. 25 u squared equals 250v plus 625, and then we put this in u and this in v. That will give us that 4x plus 3y squared equals 50 times 4y minus 3x plus 625. And so this basically means that since this is a multiple of 25, that means 4x plus 3y squared is a multiple of 25, thus 4x plus 3y is a multiple of 5. So 4x plus 3y is a multiple of 5. And this is a multiple of 5, that means this whole thing is an integer. And so u is going to be an integer. So that's one important fact here, u is an integer. And because this is an integer, so if 4x plus 3y over 5 is an integer, that means that 12x plus 9y over 5 is also going to be an integer, because this is just multiplied by 3. And if we do 12x plus 9y, and then if we subtract 5y and subtract 15x over 5, and then that's still going to be an integer. And so, which is, this much can be simplified to 4y minus 3x over 5. So that's going to be 4y minus 3x over 5. So this is also an integer, and that's this value right over here. So this gives us that v is also an integer. So v is an integer. That's one more important fact that we have gained. And next, since u is an integer and v is an integer, what this means is that for every lattice point u comma v, then there is a corresponding lattice point which is going to be x comma y, like that, right? And since we now know that u and v, they are integers, then that gives us that we can use this one again, right? Since u squared equals 10v plus 25, and since this is a multiple of 5, that means u squared, that must also be a multiple of 5, right? Because u is an integer. This means that u is a multiple of 5, because u is an integer. And let's say that this u is 5a. So if u is 5a, and then we just substitute that, then that's going to give us that 25a squared is going to equal 10v plus 25. And we can see that here, 25 and 25. So these two are both multiples of 25, but 10v, that's just multiple of 5. And so since that also has to be a multiple of 25, because v is an integer, that means that v is a multiple of 5. So this means that v is a multiple of 5. Let's call this 5b, right? So if we just substitute 5b into 10v, then that's going to give us 25a squared equals 50v plus 25. We can divide that by 5 to get a squared equals 2v, sorry, not v, it has to be b now, 50b, like that, and 2b plus 1. So since a squared equals 2b plus 1, this means that this is odd. So this means that a squared is odd. So that means that a is also odd, right? So let's call a is 2k plus 1. If a is 2k plus 1, then 2k plus 1 squared is going to be 2b plus 1. So 4k squared plus 4k plus 1 equals 2b plus 1. And so if we take out the plus 1, then 4k squared plus 4k equals 2b, like that. And if we divide by 2, that means that 2k squared plus 2k equals b. This means that b is even. And so let's call b 2m. So if we call b 2m, then that means that we can say 2k squared plus 2k equals 2m. So if we divide by 2, then that's going to give us k squared plus k equals m. So what this basically means that if our k value is set, if we have a set k value, then we have a set m value. And so we can only have a set k value if we have a set a value, and we have a set a value when we have a set u value. So this just means that if u is an odd multiple of 5, and it's odd because a has to be 2k plus 1 and 5a, so u has to be odd multiple of 5, then we have a point u comma v, which gives x comma y, like that. And so for u to be an odd multiple of 5, we see that this has to be within 1000. And so this means that u is this value, so this has to be an odd multiple of 5, and since the absolute value of that is within 1000, this means that 4x plus 3y over 5, this is going to be between negative 200 and positive 200, right? So we can move this like that. And so this is u. This means that, so we need the odd multiples of 5 that are within these parameters, right? So this is going to be equal to, so this much is 400 divided by 5. This is for the multiples of 5, 80 multiples of 5. And lastly, we have 80 divided by 2 for the odd multiples of 5. Odd multiples of 5, which is going to be equal to 40. So we have 40 odd multiples of 5, and that will give us xy values. So 40 is our answer, it's B. So that was it for the AMC 12A from the year 2014, and thank you for watching.